Hello students, let us now move to the next topic, differentiability. So here I have already taken two functions, the graph of two functions. This is the graph of modulus function. So this is a modulus function and this is a graph of a polynomial x square. So roughly I have drawn these two graphs. We know that, as it is clear from the figure, and also we have already studied that a modulus function is always a continuous function. Everywhere it is continuous, and also a polynomial function is always a continuous function. Now these two are two continuous functions. Now we will see whether they are differentiable or not. Now modulus function is a continuous function but not differentiable, while this is a continuous function and also it is differentiable. So both are continuous, but why this is not differentiable? Now for differentiability, a function must be continuous, but continuity only is not the condition for a differentiability. So what is the another condition? The graph is continuous, fine, but the second condition is that the graph must be a smooth graph. Smooth means there must not be any sharp edges. See here, there is a sharp point here. It is not, because of this, it is not a smooth graph, while here it is continuous as well as differentiable, because it is, first of all, it is continuous and it is a smooth graph. So with the help of these two graphs we understand continuity and differentiability, the relation. That means every continuous graph may not be differentiable. So this is a very good example. Modulus of x is a very good example, and we see that as the graph in the negative side, as the x value of x increases, the value of y goes on like this, and at point 0 the value suddenly increases. So because of this sudden change there is a sharp edge here. So because of this it is not differentiable, while in this function the graph is going on smoothly. So so for a different function to be differentiable, the condition is that it must be continuous, it must be a continuous graph, and also it must be smooth. It must be a smooth graph. Now in order to check continuity, we have learned the left hand limit must be equal to the right hand limit, and it must be equal to the function at that point. Now for derivative, in order to check, we know how to check the continuity. Now the second condition is the smoothness of the graph. We have to check the smoothness of the graph using derivative, left hand derivative and right hand derivative. The left hand derivative and the right hand derivative must be equal. Now we will understand what is left hand derivative and right hand derivative. Now let us take this any graph fx, any random graph, and we see that this is a continuous graph at every point. So let us take one point A and let us check the differentiability of this graph at this point. What is the condition we will learn. Now if this point is A, then let us take another point A minus h, where h is a positive number, and if we minus h from A we get a number smaller than A. Also if we have a point A plus h, that means h is also another same positive number, and if we add h to A, it gives a number slightly bigger than A. Now as the point at this, the value of fx at here, the value will be f of A minus h, and at this point it will be f of A plus h. Now in order to learn the smoothness, we use the slope of the graph, the concept of slope. If we join these 2 points, now these points, it is not a tangent, it is a secant or chord. Now if as this point becomes very close to A, that means as it approaches A, if the slope here, slope of A, B and slope of BC, as this point comes closer to A, if the slope of line AB merges to A, and also as this point comes closer to A, and the slope here again, if the slope merges to A, then this function is said to be differentiable at point A. Now how we write slope? Slope of AB will be here here f of A is the function at point A, f of A minus f of A minus h divided by here A minus of A minus h. This is the slope, and here we have A and A will get cancelled, it will be minus minus plus h. So slope of AB will be this, because we know slope of AB is if x1 y1 and x2 y2 are the coordinates, then the slope of this line will be y2 minus y1 divided by x2 minus x1, and slope of BC will be equal to here BC f of A plus h minus f of A divided by A plus h minus A. A and A gets cancelled, so f of A plus h minus f of A divided by h. Now if we put limit to these slopes, limit of h tends to 0, it means as h becomes very close to 0, as h approaches 0, this function is called the left hand derivative, and this also, as h tends to 0, this expression is called the right hand derivative. So as h becomes very close to 0, if the slopes are equal, if the slopes of AB is equal to BC, then it is said to be derivable at that point A. So we write left hand derivative equal to limit of h tends to 0 f of A minus h minus f of A divided by minus h, and right hand derivative h tends to 0 f of A plus h minus f of A divided by h. So here we got the left hand derivative. If we take f of A minus h to the other side, it will become, here we have minus. So this is the left hand derivative and the right hand derivative, and for a function to be derivable at x equal to A, this condition must be satisfied, that is left hand derivative must be equal to the right hand derivative, and if these two are equal, we say the function is derivable at x equal to A. Now if suppose we got this to be equal for the point A, then these two must be equal to some finite number, and in this case at this point A, the finite number will be equal to the derivative of the function at that point A. So we have to remember this. So with the help of these two graphs, we understood that every continuous function may not be differentiable. Here clearly modulus of it's a continuous function but not differentiable. So what we have to remember, there is also a theorem that every differentiable function is continuous. That means every differentiable function will be continuous, but every continuous function may not be differentiable. So this is a very important point we have to remember. That means if a function is differentiable, it will be continuous. That means, or we can say that a continuous function is differentiable, or a differentiable function is always continuous, but a continuous function may not be differentiable. Every continuous function may not be differentiable. In this case, this is a continuous non-continuous function but not differentiable. It is a continuous function also differentiable. So we have to check the condition for differentiability. Also, for this, at x equal to 0, the function is not differentiable. If you remember few points, it will be easy for us. If left hand derivative equal to right hand derivative equal to some finite number, then the function is differentiable and continuous. This is the first case. If it is both are equal and equal to a finite number, then differentiable and also automatically it is continuous. Number 2, if it is not equal, if both are not equal but individually they are equal to some finite number, individually they are equal to some finite number, then they are not differentiable because the left hand derivative does not equal to right hand derivative, but it is continuous. If they are equal to some finite number individually, then it will be continuous. This we have to remember. And the third point, if both or any one of them are infinite, if both or any one of them are infinite, then what we have to remember is that they are not differentiable. They are not differentiable. And what about the continuity? We cannot say anything about the continuity. For this, we cannot say anything about the continuity. We have to further check again the continuity. So once it is differentiable, it must be continuous.